and welcome you all warmly for our second webinar. It's an initiative by the Chamber of Construction Industry, Sri Lanka, as well as our training partner, HWK, the German Chamber of Skilled Crafts, and we would be conducting a series of webinars, and this is actually the second. As perhaps all of you have the webinar agenda, today's title is Renewable Energy Integration in Construction Projects. Renewable energy integration into construction projects. It's a very interesting and timely theme of incorporating renewable energy into construction. Since all of us have the agenda, but I would run through this. We'll be conducting these webinars as a series of webinars on the second Wednesday of every month. And this is actually the second in that series. Right. So I warmly welcome you all here for this webinar and would invite Architect Jayantha Pereira, who is actually the president of the chamber, as well as the president of the Green Council. That is, this is done in partnership with the two of us, and he would make the opening comments, please. Thank you.
Thank you, Lal. Good afternoon, everyone. It's a pleasure to welcome you today for the webinar dedicated to one of the most dynamic intersections of our time, renewable energy and construction. As the global demand for sustainable development accelerates, the construction industry stands at a powerful crossroads where innovation meets responsibility. The integration of renewable energy sources such as solar, wind, and geothermal into construction projects promotes sustainability, reduces environmental impact, and enhances cost effectiveness. This transition towards renewable energy is influenced by decreasing costs and the growing recognition of the importance of eco-friendly practices. This webinar aims to explore how renewable energy can be effectively integrated into construction projects from design to execution. We will hear from our experts who are shaping buildings not just to shelter us, but to power a cleaner, more resilient future. Whether you are a builder, designer, policymaker, or simply someone passionate about sustainable solutions, today's dialogue promises to offer insights that inspire action. Let this session spark fresh ideas, deepen collaboration, and remind us all that sustainable construction is not a distant goal. It is a choice we can make today. The future is built not only with bricks and steel, but with vision, value, and the energy of change. Thank you for being here, and let's get started. Over to you, Lal. Lal, you are muted.
Are you fine?
Now we are okay.
Right. Thank you, Architect Jayantha Pereira. That was very lucid on what we hope to do in construction with the sustainable paradigm for the future. Right. Now, I would like to introduce our keynote speaker, Mr. Johannes. Pardon me if I use only your first name because I find it difficult to pronounce your other name. So it will be Mr. Johannes, please. And he is a managing director of a renewable energy company in Germany, and he would speak to us on renewable energy integration into construction projects as from now on, please. Thank you. Mr. Johannes, it's yours now to speak to us, please.
Thank you very much. Thank you for the nice introduction. That's totally fine. I strive to be actually present here in commercial industrial solar systems. Like my participants of the workshop are even here with me and following the webinar as well. And I'm very honored to be here. But like I'm still struggling as well with all the different names. But I'm happy to be part of that webinar series, and I just want to actually highlight what you already have mentioned. I think the time of those the timing of that 1 hour is so short. I think we cannot go far into deep depth, but I think sparking ideas was the right highlighted phrase we could use here. Is like we just want to give like a rough overview of what is possible with a building and construction and the integration of renewable energy within this framework. So like I just wanted to start off, not waste too much time. Yes, my name is Johannes Hertlein. I'm the director of Solienda GmbH, which is like a renewable energy project company in Germany. Like we mainly do consulting or renewable energy constructions for residential areas. We are not particularly a building company, but like we try to integrate renewable energy as much as possible. My screen, I should be shared already. Please let me know if you don't see it. Otherwise, I would just a quick introduction. I think that was already said as well, is very important for integrating the renewable energy in the constructions. Then talking about global trends, what is happening, and I wanna always compare the situation in Germany with the one in Sri Lanka, just because as for most and foremost, like of course it's a German-Sri Lankan partnership, but as well as like Germany has tried to push the way forward in this kind of technology, and so far we have really tried to achieve a lot of progress. Although I think it's time right now that you can see countries like Sri Lanka that they even taking over and pushing it far more than we could do. So then I want to showcase some of the possibilities of renewable energy in generation, especially in the small sizes for the construction sector. Then I want to quickly highlight like the possibility of energy storage solutions, which was actually just part before we closed for that webinar, was part of our workshop here as well. And then of course I'm happy to invite you for a quick question and answer session at the end of the webinar. Yeah. So like here there are already some key figures. I don't want to go too much into details. Was said as well as like the building and construction was already responsible for 1/3 of the global energy demand, and even the same as the carbon dioxide emissions. So like you cannot say that's a small problem. No, it's like actually 1/3 of the global greenhouse gases is caused by buildings. Is for any things like heating or cooling or whatsoever, and that includes domestic, commercial, industrial, or even the big industries. That's everything is covered in that one. So Electricity consumption has grown significantly in the past years by 60%, and for the building energy demand, it was going up by 37% for in 2020 in 23. So it's like was a raise of 31% in 2010. So that's because of more appliances like digitalization, as well air conditioning. That's going to be major usage in the next coming decades, because electrification rates in the tropical countries are growing stronger than anywhere else. And we are sitting here in a room as well, where 2 air conditioners are running, because otherwise you cannot just beat the heat. The energy consumption intensity is 130 kilowatt hours per square meter, which you can imagine, like, that's doesn't sound a lot, but like if you compare it to the worldwide energy consumption or buildings you have, that's quite a lot. And unfortunately, the efficiency has not been there to reduce this number significantly. But good news, the renewable energy sector has actually met 70% of the building energy demand in 2023, which is already something, but that includes everything from on-site generation, where we want to focus today, as well as grid-supplied renewable energy sources, which means like that the renewable energy is produced somewhere else, but then transported by the grid. But nevertheless, we have seen quite a growth in that respect as well. So 70%, there's still room for more, but we are confident that we see some more growth on that one, especially since like the photovoltaic, the solar business in the residential and commercial sector has been growing significantly in the past years. So now, as I said, like I always want to compare a little bit the German side with the Sri Lankan side. What are the main differences? And like, to be honest, like both countries are not really good for comparison, but like we just keep it as we wanna highlight on that one. The Germany and basically Northern Europe and Northern America, as well as like the main energy consumption in houses and commercial industrial areas is basically space heating. Why? Because like we have our cold winters, and like we need to warm our places, because otherwise we will be freezing. So 83% of our energy actually goes into our space heating and the hot water on the domestic side. Whereas in Sri Lanka and in other tropical countries, most of the power, actually electricity, mainly goes into cooling. So AC or ventilation, and then followed by lights and other small appliances. The same picture in the commercial sector. Space heating over there is still 50%. It's not as much, because like you run much more equipment and much more lighting throughout. But it's the same still in Sri Lanka. The same cooling is the most prominent, like, and biggest single consumption, and the lighting and equipment is just next to it, that one as well. So the drivers, as I said, is first of all in Germany and in the Nordics is more the cold climate, which needs the heating, and tropics, and in Sri Lanka specifically, it's the hot and humid climate, which requires cooling. Usually, like you would say, like probably hot water or cooking is done mainly as well by electricity, but I think here mostly in Sri Lanka it always depends, like if it's rural or urban, but like gas or other sources of energy can be used for the cooking part as well. Good. So looking at the Sri Lankan electricity consumption in the past years, you can see here as well is like there has been a constant growth of electricity consumption. It's like it has the different colors of drivers, and you can see it here as well. It's like all the sectors have grown more or less like simultaneously. It's like the domestic sector in green, followed by the red industrial, and then the public and commercial one. Those are the main electricity consumers, and street lighting and religious and charitable is quite low. You see there's a small probably COVID and economic crisis related dip, but like I think it has recovered already in the recent years. And you can already see, like, if when we are talking about those main drivers, and we know that the space cooling is one of the most important things which is used for, then we know, okay, we must make sure that actually we don't have to cool those those buildings with electricity, but like we should apply more energy efficiency. And although it's not part of this webinar, I think the major step should be always, when you talk about like renewable energy or energy efficiency in construction, then you should always focus first on energy efficiency. So you don't need actually to produce the power, just save it right from the beginning. So insulation, proper roof shading, all those things can already require less energy to cool down the buildings just from the right hand. And then the second step should be energy. So just for us to understand like how we can apply renewable energy in the construction area, this is a typical week of consumption. Here on that axis in the downer part, like you see like days, it's a 7-day week. And it starts here on a Sunday, then it's a Monday, that's 24 hours. And you can see always very nicely, there's always a peak at lunchtime, at midday. This is like when most of the offices and commercial industries are operating, when they need the cooling. So you have a lot of electricity consumption. And then in the evening, there is a specific peak where everybody, even the residentials, they go home, they cook, they watch TV, they have their lights on. So that's a typical day in Sri Lanka, where you have like a bell-shaped consumption caused by the industry and the commercial, and then a peak in the evenings for the households. And what you can see here as well very nicely, that's really, this is the case. This is a Sunday. You see that bell is not there because like the industry and the commercials are not really working, and the same for Saturday, which is like the bell is a little bit lower. Okay, so what kind of renewable energy sources could we apply in construction? I've split them in 3 main sources or main categories. There's first of all, of course, we are thinking always about solar energy, which is obvious as well. It's like photovoltaic panels, which are producing electricity. They can be put on rooftops, on facades, which is like called building integrated photovoltaics, and even into windows. So that's possible for photovoltaics. They are quite common. I've seen quite a lot of them right now. Even if I look outside the window right now, I see a solar panel on top of a roof on the neighboring building. They are quite common. What I see as well is like I see a lot of, see actually 6 solar water heater systems just next to each other, providing hot water for showering, and as well for hot water in the bathroom or in the kitchen. And even like it would be possible to have like solar thermal systems for air heating as well. So just to get hot air for processes. Second main category is like wind energy. Of course, when you think about like that integrating into construction sites, like we cannot think about like that 100-meter high wind turbines generating 1,000 or more kilowatt. We have to think about small scale wind turbines, which really are on site, probably on rooftops, where they can harvest like better winds over there. And then of course, always possible, hybrid system combining both the wind and solar. Other sources which could be incorporated, like other sources of renewable energy, which could be incorporated into construction, would be geothermal, which is like basically using the energy from the earth to actually use it either for heating or cooling, or biomass, which is either organic waste or other organic matters, which could be used for most of it for heating or for power in a specific project which have to be designed on that one. Long story short, let's jump into the matter. Let's start with the probably most unrealistic one for Sri Lanka. Why? I will talk about it in the next slide, but like that's geothermal energy in Germany. What does it do? Is like geothermal energy is used mainly for heating and nowadays even for cooling of buildings in Germany. How does it work? You either take the hot or cold air from outside, or even better, you take like groundwater or water stored somewhere deep in the ground, which is either warm or which is cold, and you pump that water through some pipes, and then you can integrate like a so-called heat pump, which is like similar to working principle like a fridge. So like there's a compressor and there is a mechanism which allows you to gain actually more heat or coolness from the soil as it is there. So you can raise the temperature of 1 liter of water when you take it maybe from the ground with 8 degrees Celsius. You can lift up the temperature up to 50 degrees by using this compression method, like it is used by the fridge. The fridge is getting cold inside, hot outside. You can use that similar to heat your home or your industry. It's very natural, so like it's you don't require any kind of input, because like the power is the heat is down in the soil or in the air, and you only need to run that pump, and you can usually use it, as I said, like in Germany, use it for heating, but you can even use it for cooling, which would be the case in Sri Lanka. And I think that's already where the problem starts. Like I did some research whether there is any kind of project here in Sri Lanka, and there was not any geothermal energy project in Sri Lanka. So I checked where else could you find it, and I found projects like, or at least studies conducted in Japan, in Tokyo, with a similar climate. And the problem you face in general in the tropics, if you want to use the geothermal energy for cooling, is that the underground temperature is far higher than you would find it in Germany. So like in Germany, like or in Europe, like it's the underground is very, like the soil is quite cold, but here it's just like, because there's an overall higher temperature, so you would not find any kind of cold medium. Medium is like either the soil, the water, or whatever, which you can use for cooling. So, but you need this kind of cool surrounding to be actually able to run your cooling machine. So that's probably difficult. What they have achieved in that study in Tokyo is like they tapped into cold water which was in the underground, and they found that mainly in mountainous areas, or what they write like in places near shore, like where the shore is not far away, because like the sea is usually a little bit colder. So that could be something you might find in Colombo because of the sea next to it. But like I haven't found any study on that one. Next one, is biomass energy. And like the picture you see here, that's actually my own residential house in Germany. That's my cellar. Here on that side, you see a wood pellet stove. So like small pellets made out of sawdust, and that's full automatic heating. So like I've got a tank where the pellets are actually transported to the stove. It burns it, the water will get hot, and then it's stored actually in that tank, which is like the black round tank in the back for the night or whenever I need it, and then it's transported via those pipes to all the rooms. So that's a common use right now, the biomass. Like you have different ones. You can use it like as wood pellets, as I said, or even wood chips, like bigger chunks. You can even use biogas or biofuel. This one even can be burned in engines, like just like as a car engine. You can just run them on gas as well. Then you can run a generator and you produce electricity, and then you take the excess heat as well for heating. You can use it for cooling as well, but like it's very difficult because like it's a little bit a strange setup. You burn something which generates heat, and that you use absorption method to actually produce then cold water or cold air on the other side. So it's a little bit of a complicated process. It doesn't really have much of usage in Europe, but like biomass has an advantage in building construction because the fuel is available and the energy contained in the fuel is quite high. So I only need a small storage for my pellets to run through the whole winter, which is great, which is very good. And like as soon as I need it, I just burn it more or less. It's not like the wind or the sun where I have to wait for the sun to shine. It's always available. The disadvantage is like it's more complex and it comes with its cost. So in Sri Lanka, I haven't seen and I haven't actually found any small-sized biomass plant. So there are power plants, which I learned they are called tendros here in Sri Lanka. This is like I think it's a 20 megawatt or something like this. It's already in the megawatt. So it's not really for residential, and you can see it's like that's the whole plant. That's not the building it supplies to it, but that's the whole plant. So it's quite big. But that one can be used to burn rice husk or any other biomass and produce as well. Usually they produce steam, like they boil water, they produce steam. It turns like the turbine, and then you generate power with it. But most of them, they are quite big, above 500 kilowatts. So that's not an application you would typically use for a residential house or even like for a small commercial industrial setup. You wouldn't use this kind of system because it's just too big, and like you have to take care that this process is not interrupted. So you need operation maintenance, like you need people who can actually operate that stuff. So it's like it's a project in itself, which is probably not feasible at most of the sites we are envisioning. So coming to the one of the major possible energy sources, which is like the wind energy. In Germany, yes, you see small wind turbines. Here is like an office building, even close to Frankfurt, where our project partner is located. On top, there are 16 wind turbines. You see them, these ones, like this funny-looking structures. They are the wind turbines. They turn vertically, and they generate about 8,250 kilowatt hours per year. If you do the math, then you realize like the power is quite expensive, even from them, because they are not cheap. And that's the biggest problem with wind turbines, micro wind turbines, specifically in Germany, because like you need to invest quite a lot of money, and the production usually is quite low because it's very difficult to find good local wind conditions. The wind condition depends really highly on the site, and not like solar where you can have like satellite imageries where you can say, okay, this is a good site or this is not a good site. Like a wind turbine can work on one side of the building, but can be a completely disaster on the other side of the building because maybe there is shade or there are quite high turbulences, and then this small wind turbine will not work. So it's a very, very specific source of energy. You need high maintenance because, like, of course, you have your moving parts, like the wind turbine is turning around itself, it's spinning and stuff like this. So you need to make sure that you maintain it well, because otherwise it could destroy. And something like you should not underestimate is, since it's turning quite fast, especially in heavy wind, that vibrations can cause noise. Noise which is probably disturbing everyone living or working in the building, and then as well as like those vibrations, if you not mount those wind turbines properly to your building, they can even cause damages by cracking. So this is something like you always need to consider, that even the mounting of those wind turbines needs to be really engineered quite well to do that. So in Germany, in Northern Europe, like most of the time, those wind turbines, they are used mainly for marketing statements, as this is, for instance, on a company which is trying to offset all their emissions and like is a very ecological friendly company. So for them, it's more like a statement that they are even trying to generate their own power on top of their roofs with their own wind turbine. Then they actually need the power from this wind turbine. The same like the biomass. I haven't found many sources in Sri Lanka selling micro wind turbines. I've just found like one website, which is even linked here in the presentation. It's Microchip. They are selling wind turbines like from 240,000 rupees to 580,000 rupees, which is probably a decent price. It's for that wind turbines, but you always need to keep in mind that those wind turbines probably will not produce a lot. It's like, as you can see it here, it's like this graph is provided by the manufacturer, and it says like when you have a wind speed of 5 meters, which is usually quite a good wind speed, we would have like on average, maybe even on a near coast, maybe in Colombo next to the beach, you would have that speed. That wind turbine, and that I'm even talking about the bigger one here for 580,000, is producing about 20 kilowatt hours per month. So you already see like the power output is extremely low. It's like a single solar panel probably will do more in Sri Lanka. So I don't think that's quite feasible. No? Here I even wrote like that for the bigger one, it's like 30 kilowatt hours at 5 meters per second. Here is 5 meters per second, 30 kilowatt hours. That's about like a saving of 1,600 rupees per kilowatt. Per kilowatt you're producing per year, so you can see how long it will take actually to recover the cost of that wind turbine. So I don't think that's going to be a big market for Sri Lanka. Coming to the last and probably most relevant source, that's solar energy. Solar energy, like as we said at the beginning, you can split it in two parts. Like in Germany, you quite see it nowadays, you quite see it more frequently. Like you have two systems on top of your roof. That's a flat window-based solar water heating system. So like there's a liquid, anti-freeze liquid passing through small pipes here in these chambers, like covered by glass. The water gets hot, as you can imagine, and it's pumped into this kind of storage you have seen on my picture with a biomass plant in the cellar, and heats the water over there. Like we don't have that solar water heaters which are on top of the roof. Like we have a circulated system, that's how we call it here, because of the cold temperature in winter. And next to it, that's solar PV. PV means like photovoltaic. That's actually producing directly out of the sunlight, it produces electricity you can use in your house. You can run appliances, you can charge your phone, you can heat your food, you can do whatever you want. You can even put it into heat in your heating, or you can put it in your electric car if you have one. So it's quite universal, and the excess can be even fed into the grid, and you can earn some money to it. So like the PV has a very long history. Like we started in 2000. Like our feed-in tariff law is just like hitting the 25 years. Like, so it's like it was initiated in 2000, and since then we have really put a lot of panels on rooftops and like ground mounting. So at the moment we have more than 4.8 million solar systems in Germany, and most of them are either small on the residentials or on commercial sites. So like most of them, they are below 100 kilowatt peak. So that I would call that's the roof, the construction integrated. Yeah. Here in Sri Lanka, I've seen quite a lot of solar systems as well. I've mentioned that already on my, when I just look out the window, I see two systems as well, similar to like what you've seen here, see on the picture. Like in the background, you see this thermosiphon systems, which have like the hot water tank on top. This is quite common here because you don't have to worry about freezing. You can just keep your hot water in that tank. It's an insulated tank, and whenever you open a tap, it flows from that tank into your tap. So like that's quite good. Of course, you have to make sure that your roof is strong enough, and I think that's one of the recommendations for integrating this kind of things in your building and construction. You have to make sure that that extra load of the water on top of your roof can be carried by the roof and will not produce any additional headaches. Then in the front, like you see a photovoltaic system. Now I think I'm quite impressed about like the rollout of PV here in Sri Lanka, at least like here in Colombo area. This is something like here you would use smaller systems. You use mainly for your own consumption, to use it in the net metering, and bigger projects like you would even maybe try to feed into the grid to get some extra money. I think right now it's really an interesting time. I told like my participants here in the room as well about like there's a lot of movement, and like I think not really good movements. Like there's a severe cut in the feed-in tariffs and new policies implemented in terms of solar photovoltaic, which is always not good, but there's always some kind of potential as well in this kind of changes. And like if yourself like you are into solar, like that's always an opportunity for you as well to adapt and like to see what is new on the market and can be introduced. Yeah. So I would say like solar energy really has a very high potential. There's a good sunshine, even far better than in Europe, here in Sri Lanka. And the great thing is like you have quite a low in-year variability. What does it mean? Like almost the whole year you produce a stable amount of energy. Like I was discussing that graph with my workshop participants. Maybe it's a little bit too optimistic. There is a little bit of a bigger gap in the production every year. So like that should reflect like different seasons in Colombo and the power production. So like the autumn, which you don't have, like it's probably a European concept of seasons. But like in the rainy seasons, your production is lower than the one which you would have like when there is dry season and there's a lot of sun. So like there's a difference. Nevertheless, like usually here you see like the time of the day, and this is like how much energy a solar system would produce. So you can see here already that there is a sharp increase in the production after in the morning. So probably more considerable between 6:30, 7 o'clock. Then you really start to harvest some energy. Then the peak is of course at midday. At midday, and then goes down again. And this is something like which is more or less like everywhere in Sri Lanka. Maybe in the north it's a little bit different to the south, but like nevertheless, like the island is not as big as there's a major differences. And here on the left hand side, like I've integrated some daily loads, the same curve, like it's as well as like from 0 to 24 from different sectors. So here's a residential one, here's a hospital, here's a hotel, a retail, and down there then a school and an office. And you can see here in the residential one that the peak is actually that evening peak we have mentioned before, and I've seen that one. And if you compare this line with this solar, you can see of course it's good, but it's not perfect, because the peak of the production of solar is just when the sun goes down and the solar is not producing anymore. So like the load requirement is a little bit shifted. But if you look, for instance, like at the hospital, or specifically the office and the retail, if you look at those graphs, then you see it's almost a perfect match for the solar. So if you have like a construction ongoing for this kind of setup, like commercial, industrial, or just commercial, or even the government with some hospital and some schools, solar integration is the way to go, because you can easily cover most of your energy with just like providing directly power from the sun, and that can really help you to reduce your energy requirement. So here I just want to highlight some different potentials for buildings. You can see like that one was given by a graph from the Energy Commission, like here in Sri Lanka. So you can see like this is a typical consumption for different sectors. Like a hotel, for instance, on average would be consuming 38,000 kilowatt hours. The industry would consume 5,100. The government would consume about 1,900 per building, and the general 390. So if that one is on average what you have seen here in Sri Lanka, if you have like a normal site, I have just added this kind of solar system you would require, which is like from 0.4 kilowatt peak, which is basically one panel, up to a bigger system of 212 kilowatt peak for the hotel. And then next to it, like I've just depicted the surface you would need. So to cover like the energy of a average hotel here in Sri Lanka, you would need 212 kilowatt peak, which would then cover the surface of 900 square meter. This can be either rooftop or maybe on ground or wherever. So this is, and here I just added the way I've been calculating it. So just to the end, like some case studies. The typical, I think you have all seen like solar, you're familiar with solar as well, is like what is possible as well, and what could be nice and aesthetic when you talk about construction. Then you can just use solar panels, even like in building integration. You just can avoid like your own covering of building with some panels or whatever. Like you can even put solar panels instead of shingles, tiles, or any other cladding. And this is a fully covered solar panel site. You won't see it. It looks like a glass cover, but those are solar panels integrated in the roof. In the wall, and that can really be a benefit, because like of course you produce electricity and you have a building protection. Of course you have to make sure that the costs are not skyrocketing, but it's a nice concept. It can be very beneficial, although of course in the tropics, like if you have a vertical solar system, your yield will be lower. If you use it, for instance, like here as a as a window. You even have additional shading for your coverage. That's something like you can consider. But like, of course, there are challenges. You need to have like fire protection, weather protection needs to be checked as well, and like all those kind of things. Complexity of planning will increase because, of course, you have to make sure that everything is working. Cost is always a problem, and expertise is something like which is always, if you integrate it at the beginning, then it's going to be a bigger problem. Okay. Yeah. Then we have just done that here in our workshop. Integration of energy storage is like basically, of course, it's obvious. This is like, you have seen that this is the energy production by solar, and then we have here our peaks, especially for residential, which is like then later in the evening. The idea would be that you would just store the energy in a battery and just use it in the evening. I think this is the way you go to go. We have been just calculating here together with our participants, like at the moment with the current tariffs and feed-in regime, that's economical, not feasible. But of course, if you use it as a backup for probably energy outages, or if you want to cut your peaks, then that's a good option and should be always considered. Here's a case study as well. There is a 2 megawatt hour storage already implied in Sri Lanka. It's a Jehovah's Witness, quite a big one. Very nice to see. So that could be an option. Good. So coming to an end, just want to highlight like a smart home system, which I think you should always, when you talk about construction, you should always maybe consider. The world is going to be changing. It's more digitalization. It's more automatization. Integration and communication is a big thing. So the thing is like what you want to do is like you want to merge the generation maybe by PV and like the other grid options like energy sources like grid. You want to merge them and you want to control your appliances in the house, like the inverters, which is converting the energy from the sun, your battery. You want to merge that together and control them, so to make the most use out of the power you have gained internally, which then can increase your independence and can reduce the strain on the national grid as well, which is becoming more and more of an issue as well. So last slide before we end and go for some question and answers. So buildings have really a high energy consumption, not only in Sri Lanka, but specifically as well here for the cooling part. Then reasons are it's the hot and humid climate, which requires the cooling, energy efficiency to actually reduce the necessity of that cooling should be the highest, should have the highest priority and offers really even the biggest saving potential as well. You can apply several renewable energy sources into buildings. We have seen different things like biomass and solar heaters. That's something like I would definitely go for. Maybe hot water production. Photovoltaic is the best if you think about like electricity production for the construction integration, and this one can be installed, for instance, like on rooftops, even on carports, like to cover some shade as well. And then you can have like the building integrated photovoltaic systems, as we have seen, as the facade or even the windows. Then battery storages, that's an option as well. They can improve the efficiency of a solar system, and they can add additional autonomy for the user, as well as smart home appliances. They can actually improve efficiency as well by matching your demand with the supply from the rooftop, for instance, if you have a solar system, to whatever you need it for, air conditioning, hot water, or EV charging or whatsoever. So this is a very short introduction. Please feel free to have to send any questions. Maybe let me check the chat as well. These are my contact details as well. Thank you very much for your participation, and handing over back to the organizers. Thank you.
Thank you very, very much, Mr. Johannes, for that very informative presentation. And twice, I think Mr. Johannes mentioned about the workshop, which I skipped a beat in not mentioning to you all. Mr. Johannes is here with us on a training project, and right now he's conducting a workshop on commercial and industrial solar projects on the design and simulation of economic analysis for 1 week with member companies of the Chamber of Construction Industry. And as Mr. Johannes mentioned, questions would have arrived at the chat box, which you would field, I believe, Mr. Johannes. And as for questions, may I start with a question, please? The question
Please.
being, yes, the question being that, you spoke of the tropics, and design, particularly design in the tropics, is the ventilation part is of great importance for cooling. As we have been taught in the Middle East, particularly, the thick walls, the atriums, the passive ventilation, and such, and even water curtains, right? Now, when we speak of energy efficiency in buildings, if a stream of cool air can go through the building, energy efficiency would be enhanced by having the temperature drop. And when you mentioned of wind energy, which is not very prevalent in Sri Lanka, as you said, if by the solar energy, the wind turbines could be made to work more efficiently, so that there is a stream of cold air coming into the building, or cool air coming into the building, perhaps also being enhanced by a water curtain, probably the temperatures within the building could be reduced. And that may be one way of, particularly in the tropics, of instead of air conditioning, where we would have the temperature at a lesser degree. It's just an idea, just a thought that I had, perhaps, which I would like to present to you, Mr. Johannes.
Yeah, no, thank you very much. I think that are valuable inputs already, because like that's exactly what when I talk about energy efficiency, I think that's exactly what is meant by that clause, like that especially in the tropics, like you have to think about other things, like especially you're looking at to cooling instead of heating. Like when we think in Northern Europe about energy efficiency, we try to actually preserve all the heat in our building by adding more insulation, which is probably not the way you should go here in the tropics. Now, exactly as you said, like you would allow fresh air to go through the building, like to circulate air, cold air, like including water and stuff like this. So this is exactly the way you should. I think it should go as well. And then the second step, rightly as you said, should be like integrating then solar systems and other systems like to support this kind of energy efficient measurements, which have been already integrated in the building. Yeah, I totally agree. Thank you.
Thank you.
Yeah. I see like there are two questions. One is like Sri Lanka is like surrounded by oceans. Why don't we use the waves for energy source? Like this is actually what I've even discussed with one of our participants, and like he's trying to have like a pilot on that one as well. Of course, I mean that's really obvious, nah? Especially tidal waves is a constant flow of energy, and there are different ways of possibilities how you can use them. Nah? Like unfortunately so far, and I really don't know really why. I think it's the biggest problem is usually corrosion with this kind of setups, because like the air and the water is very corrosive, and you need proper materials who can withstand that harsh conditions. But there are ideas how to use that power. Even on a constant basis. Nah? Whether you can really integrate that then into construction, that's a different story, or which scale you use that, whether big scale or smaller scale. Nah? That's something like you need to see. But I think it's worthwhile. There are pilots being conducted, but from my knowledge, none of those technology has been so far commercialized that you can really go into it and buy it. Okay, then second question here is like the future trends and strategy for renewable energy in each country, Sri Lanka and Germany. That's something like we've been discussing actually here in the seminar for almost half a day already. It's like here in Sri Lanka, but as well in Germany, the progress in renewable energy generation has been quite big. So I think in the past, the idea was always to really push as much renewable energy into our national grid, into the whole system, to really make the first step and the first move. But the problem is, like, you always in a national grid, you always have to match demand and supply at the same time. And I think probably you've heard about like that just a couple of days or weeks ago now, like there's a major power outage in Spain, which was causing a complete blackout. And even in Sri Lanka, I think by the 9th of February, there was a major blackout as well. And that actually, although I think the official statement, I read something about a monkey, but I'm not sure whether that was real cause. But that's something like where renewable energy has to take over more responsibilities right now. So like we cannot push any longer just like I would call it stupid renewable energy into our systems. We have to make sure that demand and supply, they match, and that we control this kind of renewable energy. And this is something like we see right now with all the governmental changes, as well in Germany, as well here in Sri Lanka, that we need to think about in future, how can we integrate that better? And I think like there are two things like how we can do that. It's one of them is storage. Energy storage is something like where we can take excess supply when there is low demand and shift it to times where there is actually high demand but low supply. That's one thing. And then I think the second buzzword I would use here is smart grid, smart appliances. Everything needs to be smart. What does smart mean? They have to be able to communicate with each other, maybe even have to do some forecast about the weather for tomorrow. Like, is it going to be a sunny day? Then maybe I will not use right now my storage or whatever, because like tomorrow I can charge it as well. So this is something like where we need to be more and more open for changes and more to integration. So I think that's the next step, having smart grids and smart appliances as well as storage. Good. Then there are some questions about the workshop. Yeah, I think like unfortunately we are already almost through the workshop, but I'm sure this workshop will be maybe not the last one. Now I lost my mouse. Let me see, since rooftop, let me. Okay, since the rooftop solar PV is almost linked to the national grid in Sri Lanka, is there any possibility of having mega batteries like pump hydros or gravity battery? I think yes, yeah, definitely. No? I mean, pump storage, pump hydro means like that you use the water from a lower, you pump it from a lower level to a higher level, and then you use excess power, and then you pump it back to the lower level if you need it, and you generate electricity by that. That's always a good idea to have it. Although I have to say that's always an economical question, and like at least on the mega level in countries, specifically in China and Australia, and even becoming more and more in Germany, battery storage, even on the large scale. And then I'm talking about really containers, sea containers full of battery for a large scale operation, is getting more and more competitive. And the biggest advantage is they can be deployed very fast. So like with a pumped hydro, it takes probably years and years to set it up, but like a battery container can be deployed easily, and you can even deploy it maybe here somewhere in Colombo and just use it wherever you need it. Then the next question is, are prosumers common in Germany? A prosumer is a producer-consumer electricity, so battery storage. Yes. So prosumer, yes, is someone who is actually producing and consuming at the same time. That's a typical setup we have in Germany as well. It's like this German system for specifically for small solar systems is similar to the one here in Sri Lanka. We don't have a net metering, but like we have something like which is called here in Sri Lanka net accounting. That's our feed-in tariff. Like, so you can use the electricity by yourself first, and then the excess you just feed into the grid. And that's something like we've been using quite for some time right now, specifically when the prices of solar and the battery has been going down. Like we are becoming more and more prosumers, and I think prosumer is a very good buzzword as well, which I would put next to smart. Prosumer will act smart because like they're trying to matching demand and supply. I think, yeah, the next question is about the presentation. I'm sure it can probably be shared. I will leave that one to the organizers. And then the geothermal power energy, more details. I think we can exchange that one maybe we can exchange data on that one, because like I think we are almost at the end of the time as well. Cost implications, such for Colombo high-rise buildings, skyscraper when compared with other sources. Yeah, I think, as I said, like I don't have any idea about like the geothermal situation here in Sri Lanka, because like as from my research, I haven't found any kind of pilot project or anything like this. So I think there must be some maybe university or research center first stepping into that possibility and see whether it's even feasible. So I would say, yeah, the cost implications at the moment are extremely high for this kind of pilots, because like it hasn't been done yet from my point of view. I hope that answers the question. Okay. Yeah, floating solar. That's last question. I think from here, floating solar. That's a very good idea. I haven't been talking about that one because like that was not part of the webinar, which was like in construction. So floating solar is more on commercial or even on utility. So like big systems you would feed into the grid, and the building construction side like should be just kept aside. But like, yes, I think there is quite a potential for floating solar for the national grid. Perfect. I think that was all, and like I'm happy to answer any more questions. Maybe back to the organizers in regards of the sharing of the presentation. Happy. Thank you very much for your time, for the questions. That always is very nice if you see that the topic is of interest. It's very nice to see. Thank you so much.
Thank you, Mr. Johannes. Indeed, it is a topic of great interest, and your presentation is well received by an eager audience. In sharing the presentation, if it is okay by you, I'll speak with the organizers of this webinar and link up with you all with the presentation. Thank you once again for sharing your time and the workshop as well. Our next webinar would be on the 11th of June in this series. It is on the second Wednesday of every week. And that is how it will be. And we will be hosting you all the topic, and kindly join us too. Thank you, Architect Jayantha Parra, President of the Chamber, and also the Green Building Council for getting us working on this. And thank you all. Thank you very much.
Thank you. Goodbye.
Bye.
Good.